So hello friends, welcome to the channel Learning with Aryan. So basically, today we are going to deal with the complex integration, and we have the question integration dz 2z square plus 5z minus 3 along the contour the ellipse x square plus 4y square equals 16. So our approach to solve this question is first approach is we this is a quadratic equation. First we try to solve the value for the value of z, so which are the points for singularity. So let's start. So first we factor the denominator. We have the equation 2z square plus 5z minus 3. So we will use a quadratic formula which says that there's a formula for minus b plus minus root b square minus 4ac upon 2a. So this is the value for z. So as we can see here the b is minus 5 plus minus in root 25 minus 4 a is 2 and c is minus 3. So 4 to the 8, so it will turn to be plus 24 upon 2 and a is 2, so 4. So our value would be plus minus 5 plus minus root 49 upon 4, so which in turn minus 5 plus 7 upon 4 comma minus 5 minus 7 upon 4. So here the value is 1 upon 2 and the value another value is minus 12 upon 4, that is minus 3. So these are the two z values which are also the point of singularities. So after finding the singularity points, that is 1 upon 2 and minus 3, we will analyze the contour. So we will do the analysis of our contour, that is an ellipse, which is given as uh, x square plus 4y square equals 16. So first we make it the denominator, we try to write it as a standard form. So it will be x square upon 16 plus y square upon 4 equals 1. So we know that this equation, what it represents is the ellipse with the semi-major axis 4 along the x-axis and a semi-minor axis 2 along the y-axis, and the center of the ellipse is at the origin. So this is what this equation signifies. So now we have so if we try to draw the ellipse, we find that this is a kind of a figure which is constructed. So basically we know that along the x-axis we have 4, uh, here we have 4, as we can see from the equation that this is 16, which is 4 square, and along y-axis we have 2. So these are our coordinates, and we have the singularity points as z equals to 1 upon 2 and minus 3. So we can easily see that both the points lie inside our contour. So we have to basically do the integration part for both the points. So if we mark 1 upon 2 at basically it will lie along like here only, and for minus 3 it will lie somewhat here. So these are our points, and both the points 1 upon 2 and 3, so they are lying inside the contour. So now we will do the integration. So now we apply the residue theorem, uh, which states that basically differentiate integration of fz dz is equals to 2 by and residue of f zx. Now we will write it in basically equation terms. So basically we apply residue theorem. The equation for that will be 2 pi I and the summation of residues from f to zk. So now we apply the residue theorem for the 2 points. So first we apply residue at z equals 1 upon 2. we have the equation fz now as 1 upon basically we find the both the points, that is z. First point was the 1 by 2, so z upon minus 1 by 2 and z plus 3. So this is our equation. Basically we try to find apply residue at point 1 upon 2. So what how we can apply is, so we can write it residue of fz at 1 by 2 is equal to limit z tends to 1 by 2 z minus 1 by 2 into this equation, that is 1 upon 2 z minus 1 upon 2 z minus 1 upon 3, that is so basically both these terms got cancelled and we are left with 1 upon 2 z plus 3. Now we have to put z equals 1 by 2, so 1 upon 2 1 upon 2 plus 3, so which will give us 1 upon 2 plus 3, that is 7 upon 2 into 2 7. So here comes it comes out to be 1 upon 7 for the point z equals 1 upon 2, and we can multiply it to by 2 by I initially here, or we can do it later on when we are summing up for both the points. So it will turn to be 2 by I upon 7 for the point z equals 1 upon 2. Now we will check residue for point minus 3. So we will apply the same thing, basically residue at fz minus 3. So it will be limit z tends to minus 3 z plus 3 and here is we write the equation, that is 2 z plus 3 and z minus 1 upon 2. So both these equations got cancelled and we are left with 1 upon 2 z minus 1 upon 2, and we have to put z as minus 3, so it will be 1 upon 2 minus 3 minus 1 upon 2, so it will turn out to be again minus 1 upon 7, and we can multiply it by 2 by I. So basically now the answer is very much clear, as we are getting 2 by I minus upon 7 in minus, and here we are getting it as 2 by I upon 7 in positive. So basically when we sum both of them, we got answer as 0. So basically summing up both the residues, we get answer as basically we can write it like 2 pi I upon 7 minus 2 pi I upon 7, and which is a big 0. So this is our answer. So thank you guys. So I just quickly recap what we have basically done. So we have this equation integration for 2z square plus 5z minus 3 along the contour ellipse, that is x square plus 4y square equal to 16. First we find the denominator, we take the denominator and which is a quadratic equation, and we find the z values basically which act as the singularity point as well. So we have this equation, we for finding z value we apply this formula for finding the quadratic solutions, that is minus b plus minus root b square minus 4ac upon 2a, which is a quadratic formula. After applying this, we get the value of z as 1 by 2 and minus 3. Then we basically further analyze our contour, which is an ellipse given as x square plus 4y square equal to 16. We write it in the form in its standard form, that is 16 x square plus 16 y square plus 4 equals to 1, and then we try to plot it here. So we have on our x-axis we have 4 coordinate and on the y we have 2. So then we look at our z values and we found that both the values are lying inside our contour. So we have to perform integration for both the points. Then we apply our residue theorem, which states that fz dz is 2 by I summation for residue f zk. Then we deal with the residue theorem for first for the point z equals 1 by 2, which is fz 1 upon 2. This is our equation. Basically this is how we applied for for point 1 upon 2, that is z minus 1 upon 2 into 1 upon 2 z minus 1 upon 2 upon z plus 3. So both the terms cancel out, we are left with this equation, and we put the z value as 1 by 2, we get 1 upon 7, we multiply it by 2 by I. Similarly we did for point minus 3, and after calculation we get the point as 2 by I upon 7, but in minus. After adding both the results, we get our answer as 0. So thank you guys for watching this video. If you like this video, please like, comment and subscribe to my channel. So thank you guys.